Stop blaming your student for struggling in physics. That textbook you're using has a giant hole that may be holding them back. Today, I'm pulling back the curtain on what's deliberately missing from a textbook, giving you practical strategies that are going to help you overcome it and ways to fill this gap. Your student doesn't need more studying. What they need is what textbooks leave out. Hi, I'm Robin with Centripetal Education. Textbooks come in many flavors, if you will, but they all have the same similarities and the same deficiencies in a lot of ways. It doesn't matter which physics textbook we're looking at. Textbooks come in different flavors, different sizes, but they all have the same basic material inside. One may be stronger at one area than another, and they may have different deficiencies, but they all have the same common deficiency as well. So what are textbooks good at? Textbooks are fantastic ways of delivering information. What they do is they give us usually a very clear progression of how we learn something. It starts with an introduction, tells us a little bit about the subject, gives us the reason why we're learning it, and then it gives us some information about it, and usually ends up with some practice problems. So where's the problem? Well, here's the thing. Every physics text lacks a way to help guide you through that practice. And you think in today's day and age, with all the stuff we have on the internet and all the availability, that a lot more that more publishers would actually have guided practice available online. And as of right now, at the time of this video, they just don't seem to be out there. Why? I think a big part of it is it takes a lot of work to have somebody else go through and work all the problems out, or work out what I call parallel problems, which are problems that are worded the same, have a slight, maybe the numbers are different, and they solve that instead of the problem that's in the book. Well, why would you do that? By solving a problem that's parallel to what you have in the book, you get to see it. You get to see how a professional is going to solve that problem, and then you get to try it. You emulate what they're doing using your problem. You still did the homework on your own. You still got the benefit of doing the problem, but you had somebody there to basically hold your hand. That's what really is the best way to learn this. It really doesn't matter what textbook you're using in your course. You're going to find that it does lack that one part. And I'm curious, what textbook are you using? Do me a favor and leave it in the comment below. So what I want to do today is I want to share a few strategies on how we can overcome this gap. I've already mentioned probably the best way, which is guided practice. The other one that I would bring up is do different challenges. You have to think outside the box. And I talked about that in my last video, and if you didn't see that, it's right up there. You can check it out after this one. And we talk a little bit about how you can use everyday household items and create some challenges that'll actually get you to start thinking more creatively. A third way that you could actually approach filling this gap is by brainstorming with other people. Now, if you're part of a co-op, or you have other friends that are taking the course, or you can, even if you sit down with your child and you're willing to let them bounce ideas around, this is a great way to do that. This is how industries do that. If you think about it, when an industry is facing a problem, they don't have just one person that goes out and solves that problem. They don't open up a book and follow the steps to solve that problem. If they're creating something new or trying to expand on a solution, they're going to have a team that's going to come together. They're going to collaboratively work to solve that problem. Now, sometimes it's not practical to have that team. And as we've already pointed out, many publishers don't offer any kind of resource that's going to help you get through that process. This is where a program such as Centripetal Education can step in and help a little bit. We have a membership platform that we call the Solution Library Membership that basically has hundreds of physics problems that are solved with full instruction, full explanation on why we did something, how we did something, where we got information from, what our thought processes are as we go through the situation. So we can provide that guidance to you to help fill in that gap. If you're interested in looking at the membership, there's a link in the show note below. So why is it important for us to fill this gap? Why can't we just do rote memorization? Physics is about application. It takes time to build a knowledge base And then we have to actually be able to implement that knowledge base and use it in a variety of scenarios. When I was teaching in the classroom, I used to say I could teach the entire subject in about 10 weeks if I was just doing new material. The other 30 weeks was spent with guided practice and working with my students to get them to a point where they became critical problem solvers. So tackling those techniques that the books are missing is going to put you and your student on the fast track to learn about some advanced problem solving strategy. You can watch that video here and start turning that frustration into aha moments.